Hi everyone. So today our topic of discussion is how to get the derivative of quotient of two functions. In the last video I have shown you how to get the derivative of product of two functions. So today on the contrary I am going to show how to find the derivative of quotient of two functions of a same variable. Let me take a variable as x and let two functions of x be fx and gx. So here I want to find out what will be the ddx of fx by gx from the definition of derivative. That is my intention. So for doing so, we know, let me start here from ddx of fx by gx means limit h tends to 0 f of x plus h by g of x plus h minus fx by gx whole divided by h. That is from definition of derivative. So it comes to limit h tends to 0. If we cross multiply in the numerator, it comes to f of x plus h into gx minus fx into gx plus h whole divided by h into gx into gx plus h. So this is a simple fraction subtraction. Now you can see, since h tends to 0, so I can place the value of h here as 0, so automatically g of x plus h becomes gx. So the denominator expression, it becomes gx into gx, that is gx of whole square, which I can take out of the limit expression. So I can write as 1 by gx whole square, since I have already put the value of h equal to 0 here. So the limit finally comes to f of x plus h into gx minus fx into gx plus h by h. Right? Now, how shall I proceed for the next step? Here is the trick. So I am removing the upper section now and I am writing the last line in this way. I am keeping 1 by gx whole square outside the limit, then limit h tends to 0. After that, f of x plus h gx, I am subtracting minus fx gx. At the same time, to keep the expression as it is, I have to add plus fx gx minus the fourth expression, that is fx into g of x plus h whole divided by h. This expression is same as this expression, right? So finally the above expression which has been derived, I can manipulate it as 1 by gx whole square into limit h tends to 0. From the first two, if I take common gx, then my first expression becomes to f of x plus h minus fx whole divided by h. I am segregating that to two limits, and minus fx if I take common from the third and fourth expression, then minus fx after I take common, then it will be g of x plus h minus gx whole divided by h, right? So 1 by gx whole square, that is outside of the limit. Then what is this expression? This expression is nothing but f dash x, right? And gx is somehow I can take it out of the limit, because gx there is no part of h. So it becomes to f dash x into gx. Similarly, this portion is nothing but g dash x, and fx has no contribution with h, so I can also take it out. So minus fx into g dash x whole divided by nothing, because h has been already consumed in the first and second limit expressions, right? So h has been consumed into this part and this part. So already my final expression will be ddx of fx into fx divided by gx will be derivative of the first variable into the denominator minus derivative of the second variable into the numerator divided by square of the denominator. So it becomes to, I can write it as f dash x into gx minus fx into g dash x by gx whole square, right? So let me write it in a cleaner way for both product and quotient, and then I will show you two examples how I can find out the derivatives in such product and quotient cases. So today we have derived as ddx of fx by gx is nothing as f dash x into gx minus fx into g dash x whole by gx whole square. In the previous video I have shown you ddx of fx into gx is nothing but f dash x into gx plus g dash x into fx. For showing the example in a better way, for your understanding, let us consider fx equal to x square, that is x to the power 2, and gx equal to sin x. So for that purpose, in that case, ddx of x square into sin x, let me first show you the product, is ddx of x square into sin x plus ddx of sin x into x square. What is ddx of x square? That is 2x sin x plus ddx of sin x means cos x into x square. So here this is an example how you can find out in practical scenarios the derivative of product of two functions. Similarly, if I want to find out the derivative of the quotient of x square and sin x, in that case ddx of x square by sin x will be ddx of x square, that is the numerator, into sin x minus ddx of sin x into x square, ddx of the denominator into the first function divided by sin x in the denominator, so it will be sin square x, right? So what is ddx of x square? It is 2x sin x. What is ddx of sin x? It is cos x into x square whole divided by sin square x. So these are the two very small examples of how to find out the derivative of product and quotient of two functions. So I will be preparing other videos for showing you guys how to derive the differential of different trigonometric, exponential and other functions. In that videos I will be discussing in detail how to derive all those functions. So if you guys have found my video effective for your learning, so I will request everyone to view this video and subscribe my channel and give likes as well.